So another derivative of the carboxylic acids is the acid anhydrides. And before we have a look at this, let's just kind of recap on what we mean by a derivative. So remember, this whole unit is about carboxylic acids and their derivatives. And this one here is a carboxylic acid because we have an OH. The next functional group that we looked at was an ester, which is where this little bit here is an OR instead. In the last couple of videos, we looked at the acyl chlorides, where coming off the carbonyl, we have a chlorine. And the final one that we need to look at is what we call the acid anhydrides, which, although it's a big group, it's exactly the same that we have that. And you'll often see this, probably easier to see as what comes off it as RCO and then OCO, that's the carbonyl, and then R, and you can probably see that's a little bit easier to look at when we look at this as a derivative. The reason it's called an acid anhydride is basically how it is made. The acid anhydride takes 2 carboxylic acid and basically dehydrates or removes water from it. And I hope you can see here, which I've kind of already circled, that water's given off over there. Just like all of these reactions, really, that then joins onto that carbon there, which gives us this, which is our acid anhydride. These R groups are usually, but not exclusively, the same. And in terms of, for us anyway, when we name them, we're going to assume that they are the same, okay? So here's an example with ethanoic acid. So when ethanoic acid dehydrates or removes water, there's the water over there, we get this molecule here, which is called ethanoic anhydride, okay? In terms of the reactions of these, it's exactly the same as the reactions of the acid anhydrides. And again, I'll go back to this so that we can have a look at how all of this goes together. So here's my acid anhydride, and I'll draw it out in full. Okay, and again, just like before, we've got 4 things that we need to react it with. We need to react it with water, which I'll draw here. So there's water. We then need to do it with an alcohol, ammonia, and then an amine. Okay, so just going to change colour pens. And again, we follow that same rule again. We cut between the carbonyl and the rest of the molecule. We take that off here, which I hope you can see that when I do those, in the red box here, or in the red circle, I've got my RCOOH. So I get a carboxylic acid, and then, of course, this oxygen here joins onto that carbonyl there, which gives me another, in this case anyway, carboxylic acid. Okay, so let's just kind of change a few bits here. So that's the reaction with water. Okay, and let's just kind of change this and make it an R group so that we're reacting it with an alcohol instead. Okay, so we use green again. So I hope you can see here that now I'm reacting it with an alcohol instead of water. Okay, so again, just like before, I'm going to get my carboxylic acid here. But what is different now is I'm going to get my ester instead. Okay, so any of the derivatives with an alcohol will give you the ester, and it will either give you water or HCl if it's with the acid chloride, or in this case it will give you the carboxylic acid. Okay, let me change that now to the third one, which is ammonia. So let's change all of this now to ammonia. And what we'll do is we'll get rid of all of this molecule here, and we'll kind of start from scratch. Okay, so ammonia is this, and again the bit in red is going to form the carboxylic acid, which we've got down here. And what we've got in addition to that is RCONH2. So here you can see we've got the amide, just like we had before. It's reacting exactly the same way. Okay, if this was reacting with an amine instead, that would be an R group, which means that one of these would also be an R group, which would give us the N-amide. So you can see that so long as we keep following this process where we cut between the carbonyl and whatever the derivative is, and then join the rest of the molecule, take a hydrogen off the other thing and put it together, we can always work out what we're going to get here. This changes. If it's a carboxylic acid, we get water. If it's an acyl chloride, we get hydrogen chloride. If it's an acid anhydride, we'll end up with carboxylic acid. In all of the cases here, what we get is, with the water, we get the carboxylic acid. With the alcohol, we get the ester. With the amine, we get the amide. And with the primary amine, we get the N-amide every single time. Okay, so let's just go back to having a look at these then, and you'll see that it's exactly what we said. So we cut it here, okay, cut that there, and what we end up with is our carboxylic acid. That's the blue and the red bit joining together. Okay, if we're doing it with an alcohol instead, okay, so remember, cut it there, cut it here. So the OR now goes on the carbonyl, which gives us the ester. If we're doing it with ammonia, so again, we cut it here, cut that there, and then the NH2 will go on the carbonyl, which gives us the amide that we've got here. And then the primary amines is where one of the hydrogens in ammonia is now an alkyl group. Cut here, cut there, join the two together, gives us the N-amide and the carboxylic acid. Okay, so that's the reactions of the acid anhydrides, and I hope you can see they're identical to the really the reactions of the acyl chlorides that we've done previously.